Dear friends, in this video, we will discuss a few important questions at the black belt level examination. Particularly, these questions will be related to the analytical type. Let us see. What is the area contained within -1 and +2 standard deviation of a normal curve? So, in a normal curve, within plus or minus 1 standard deviation from the mean, 68.27 percentage of the area will lie. But now the question is -1 and plus or minus 2. We know plus or minus 2 will be 95.45. The answer is between these two, right? 0.8185 and then 0.8581. So we really need the graph to answer this question. So let me just try it for you with a pen. See here, this is the normal distribution curve. This is the center, and -1, and this side is +2. So we know this will be approximately 34%, and this will be approximately 47.5. All right, because this is -1, this is +2, right? So 34 and 47.5, how much it is coming to? 81.85. So this will be the area, and this will be the answer for this question. Hope you are able to understand. The final exam score of an institute has a mean score of 74 and a standard deviation of 6.8. The exam scores follow a normal distribution. What is the distribution for the mean exam score of 50 students? See, generally, what is the distribution for the mean exam score of 50 students? Yeah. So this is a normal distribution of final exam score, right? So whether you are monitoring your distribution in the form of X bar or X, you need to know. So very clearly, we wanted to have a distribution of the exam scores, not mean of the exam score. The option is between C and D only. And then the mean score is 74 and the standard deviation is 6.8, and that is written here. So the answer is C. Then now the normal distribution. For normal distribution, the mean is 80 and the standard deviation is 2, where X is the mark scored by the green belt students in mock test. What is the probability that his score will lie between 75 and 85? Actually, we need to do this probability calculation in Minitab. So I'll show you in Minitab in the end. Similarly, find the quartile Q3 in the normal distribution with the mean 80 and the standard deviation 2. Once you know the mean and standard deviation, you can go to Minitab and then view probability option. In that you can set the distribution as normal with the mean 80 and 20, and then for a probability of 75%, you can find out the probability of for the point below which 75% of the curve lies. That will be found to be 81.35, and that will be the answer for this question. So we'll practice this in Minitab. The black belt is developing a failure mode and effect analysis in a software development unit. The following ratings were developed for the failure mode due to wrong coding. So severity is found to be 3, occurrence is found to be 2, and detection is found to be 9. What is the risk priority number? So risk priority number is always the multiplication of severity ranking, occurrence ranking, and detection ranking. 3 into 2 into 9. So 3 2s are 6, 6 9s are 54. So 54 is the answer. Find the sample size for one sample Z test given the following. Hypothesized difference in mean is 0.5 and population standard deviation is 0.75. Power of the test is 0.95. Confidence level is 0.95. So these are the conditions you need to do a one sample Z test to gain the confidence level of 95%, right? And power of test of 95%. And what will be the appropriate sample size, right? If you just feed this option either in the Excel template or in the Minitab software for sample size prediction, and you will get the answer for this question. And then an extrusion die is used to produce aluminum rods. The diameter of the rods is a critical quality characteristics. The specification on the rods are 100 plus or minus 0.5. That means USL is 100.5, LSL is 99.5. The process average is 100.31 and estimated standard deviation is 0.05. Feed these values in the Excel template provided for CP calculation, and then you will get the CP as 3.3. Desktops are being inspected to check whether the following components are functional: RAM, motherboard, screen, hard disk, Bluetooth, and memory slot. That means there are 6 checkpoints, 6 opportunities. 1000 laptops are inspected, and then 238 defects are observed. Considering the collected data as long term, what is ZST? So feed all these data in the sigma level calculator, right? And having the option to get the ZST value. So the number of samples inspected, thousands. Number of opportunities for failure or 6. And number of defects found are 238. If you feed these values, you will be able to see the sigma level. Sigma level is 3.25. The dimension of a particular part should be between 125 and 130. So LSL is 125, USL is 130. An operator collected a sample of 1000 parts. Process average, the X bar is 126 and variance is 0.25. Please note, variance is given, not the standard deviation, right? We always use standard deviation for calculation of CP, CPK and sigma level. So here sigma levels are required. Go to the CP CPK calculator template of Excel, because that will also give you the ZLT and ZST. Since the data points are continuous, calculate the CPK and then interpret ZLT and ZST. See here, the LSL is 125, USL is 130, and the X bar is 126, and standard deviation is 0.5. Feed these values, you will be able to get ZLT as 2 and then ZST as 3. In MSA study based on variance, gauge R&R is 0.59 and the total variation is 0.62. What is the part-to-part variation? Please note, the formula for part-to-part variation is, the formula for total variation is gauge R&R plus part-to-part variation, right? Gauge R&R plus part-to-part variation. And so, when you want the part-to-part variation, you deduct the gauge R&R from total variation, right? So 0.6 minus this will get you this value, and since these gauge R&R values are generally given in standard deviation, you have to use the rule of square, right? You square the gauge R&R value, square the part-to-part variation, that will then take the square root, that will be equal to total variation. So you just have to do some little max to get the answer for this. A hospital want to determine whether there is any difference in the average turnaround time of report, and there are 4 laboratories. Since there are 4 laboratories, and the thing is turnaround time. So average turnaround time means 4 laboratory turnaround time is a continuous data. That means you are comparing 4 lab based on the continuous data. So this leads to ANOVA, right? One way ANOVA. At a 5% level of significance, you need to use the data, and the Excel data has been shared with should have been shared with you in Excel format. Otherwise, you can open it in the spreadsheet, and then feed the data, conduct the ANOVA. If the p-value is found to be less than 5%, then you can understand a difference exists, right? You can say the study is significant. Or if the p-value is more than 0.05, then you can ignore the difference and consider the study as insignificant. For a particular hypothesis test, alpha equal to 0.1 and beta equal to 0.05. The power of this test. See, beta is type 2 error, right? And if type 2 error is 5%, that means the power of the test will be 95%. 0.95 is the answer. Find the significance level when the characteristics value is not allowed in the extreme and beyond of 1.5 standard deviation on either side. So we know plus or minus 1, we know plus or minus 2, but now it is question of 1.5. Probably we have to look at the probability plot and to find the exact answer for this question. Anyway, I'll just help you with some manual graph, and see here the normal distribution. So left side 1.5, right side 1.5, right? So this is actually your minus 1.5. This is actually your plus 1.5. Now the question is significance level. Anything beyond this is considered significant. So what will be this area plus what will be this area? And if this is only 1.5, the answer is going to be between 68 and 95. You can find it out correctly from the graph, and then the balance will be this. I think the option could be 13.36. However, you need to check. If the correlation coefficient is 0.9 and the percentage of variation, the response variable explained by the variation, the explanatory variable is. And when you have the correlation coefficient, in order to understand the influence of the x variable and the y variable, we have to square the correlation coefficient r, right? That is r square. 0.9, when you square, what happened? It becomes 81. Actually, one of the options should be 0.81 or 81%, but here it is given as 54. So this is a small typo error. So 0.9 multiplied by 0.9 will give you 0.81. That means answer will be 81%. So 81% should be one of the options. In two-way ANOVA with one factor at 4 level and the other factor at 3 level without replication, the degree of freedom is. There are two factors, one at 4 level, one at 3 level. So the total number of experiments will be 4 into 3, 12 experiments. And so the total degree of freedom will be 12 minus 1, which is 11. Another question. In one-way ANOVA with 4 levels of a factor without replication. That means 4 level of a factor without any replication. The total number of experiments is 4 only. The total degree of freedom will be 4 minus 1, which is 3. That's it. So that's it from me, and I'll again meet you in another video with more such questions. All